today we're going to continue by looking at equivalent fractions. Now, equivalent fractions are two or more fractions that represents the same quantity. In other words, they have the same value. So if I should look at this section in my diagram here, what I have done, I've highlighted 9 parts out of 12. So that's the fraction 9/12. Now, similarly, if you follow along, you will see that there are some lines underneath that bar, my rectangle. And what we have done, each part is a quarter. So it's divided into, the entire rectangle is divided into 4 equal parts. Each part is a quarter. And if I were to match the same number of parts in the boxes, the yellow and green, we would see that this is a 3/4. So in other words, the same value or the same region, although the values look different, although the fractions look different, I can say that 9/12 is equivalent to 3/4. Now, how can we convert 9/12 to 3/4 and 3/4 to 9/12? That is, how can we go from one to the other or either direction without pictures? Because drawing these pictures, I can tell you, take a little bit of time and so on. Alright, and plus if we had much larger denominators, it really would get annoying. So let's go back to or multiplication of fractions. You will remember that if I have any fraction, so if I have any fraction, I'll write it a over b. We could write that a over b times 1. That doesn't change anything. Multiplication by 1 never changed anything. And so, but recall, we also had a way of writing this 1. So we have several ways of writing 1 as a whole number. It was 1 out of 1. Whoops, 1 out of 1. I got ahead of myself. 2 out of 2, 3 out of 3, and so on. 4 out of 4. And we could continue. As long as we had the same number in both the numerator and denominator, we knew that we were getting back the same fraction. So let's start with the 3/4. We're going to be looking at equivalent fractions, and I'm going to break this video into 2 parts. The first part is called building fractions, which is what we'll do first, and then after that we'll talk about reducing fractions. So building fractions, I'm going to start with a smaller numerator and denominator. So if I start with 3/4 and I think about this multiplying by 1, let's look at the different forms of 3/4. If I said let's multiply this by 2 out of 2, let's see what we would get. The numerators would multiply, I would end up with 6. The denominators would multiply, I would end up with 8. Let's go again. 3/4, I could write it as 3/4, and I multiply this time. I'll use my 1 in a different form. Let's do 3 over 3. Well, no problem with that. The same idea continues. So we know how to multiply our fractions. 3 times 3 is 9. 4 times 3 is 12. So I end up getting that 3/4 is the same as 9 out of 12, which is exactly what my picture tells me. So the question now comes in, how do I go from one to the other? How will I know? Should I be multiplying by 2 over 2, 3 over 3, or some other number? So let's look at a couple exercises. But to recap what we have, we would call this or look at this. Here we have a fraction a over b, and all we're doing is multiplying the numerator a by and the denominator b by the same number. Of course, the c we would not be multiplying by 0 because that wouldn't help us out at all. Alright, so this property is sometimes called the fundamental property of fractions. I know at this stage you might not be interested in knowing names, but it's important. Alright, so typically in your questions, you would be given a question like this. 3/4 is something over 16, and your job would be to find out what's the missing part, what's the numerator. So let's go through and set this up. So this is number 1, here's number 2. So we'd go back, we'd write 3/4, and I'll leave a space. I'll even put my 3/4 in the numerator. I'm trying to figure out what will I multiply by, and in order to get this denominator. Since the numerator is missing, I don't even focus on the numerator. I'm looking at that denominator. What can I do? 4 times what is 16? And the answer was 4. So anything I get there, by the fundamental property of fractions, I need to do the same to the numerator. So carrying out my multiplication of fractions, 3 times 4 will be 12. And so we can conclude that 3/4, so my answer part here, is 3/4. Its equivalent fraction is 12 out of 16. I can do the same thing, or let's continue with this next one. And again, we start off, we have 6 over 7. I will write it back again, and I'll write as all the things that we have. We know we need to multiply it by something. And the question is, what? What value will we put in? So 7 times what is 35? If you're good at division, you can also turn around any multiplication question and ask what is 35 divided by 7 is 5, right? Or multiplication, 7 times 5 is 35. If I multiplied by 5 on the denominator by the fundamental property, we have to do the same to the numerator. So we can conclude that our answer is 6/7 is equal to 30 over 35. Right? That's our answer. It's nice if you're doing these problems to box around your final answer. That way your teacher can find out or really see what you're doing. Alright. Now, as you get better, you're going to hear or see people do a shortcut way, or you might even go on YouTube and see many videos that do things much faster than I've done here. And in doing this, the person will probably do something in their head. 35 divided by 7 is 5, and then all you will see is a times 5 here, and you'll be done and say 6/7 is 30 over 35. Well, the answer is true, and that's exactly what we have. I do not want, or I want you to be a bit clearer in this. If you multiply by 5 there, please, I need to see my multiplication by 5 on that denominator. So don't leave me hanging. Don't leave and say, I have this, which is what I typically see on a paper. 6 over 5 is 7, and then I have 35, and this is 30. I will mark it incorrect. Alright. But we can do things the short way as long as you show me that multiplication by the same number, whether you do it the long way where you have that middle part here, or you just simply put what are you multiplying by in both cases. Let's try that short division my way here. Alright, so again I look at the denominators since those are what's present, and I say 5 times what will give me 20. And I say, aha, it's multiplying by 4. So I do the same to the numerator. 3 times 4 is 12, so I can conclude that my answer is 3/5 is equal to 12 out of 20. Alright? if you're just starting off, please do it the long way. But as you get better, the short way will also work. Finally, before we leave this section and go on to the next, which is about reduction, there are times that instead of just being given that denominator, as we're seeing here, we have a numerator being given and an unknown denominator. It's the same principle. So if I were to do this a long way, 1/3, I don't know what I'm going to get. I have 7, and we have 1/3. What am I multiplying by in order to end up with that numerator? And 1 times 7 is 7, so I do the same for the denominator. 3 times 7 is 21, and I'm done. So 1/3 is 7/21, and that's my answer. Right? Last one, and let's do that again. If we want, we can even do this the short way. I can say 3 times what will be 18? 3 times 6. So I have to multiply that denominator by 6, and I end up getting 3/5 is 18. 6 times 5 is 30. And there we go. That's our answer. Right? And so that's finding equivalent fractions, and we're starting from what we call a reduced fraction, or they're lower. Both numerator and denominators, the numbers are smaller, and building to a higher number by multiplying both numerator and denominator by a common number. Right? So I'll see you next time.